Today, we're diving into a real cosmic mystery. We're looking at a star that seems to have a split personality. On the one hand, it's a steady, predictable traveler moving through space, but deep down, its heart is chaotic and totally unstable. So, how can both of those things be true at the same time? All right, let's set the scene. Our story kicks off in a patch of sky you've probably never even heard of, the constellation Camelopardalis. Yeah, that's a mouthful. It's the giraffe. And hidden away up there is the star we're talking about today. And we're not talking next door. This object is 3,300 light years away from us. To put that into perspective, the light we're seeing from it tonight started its journey around the same time the Iron Age was getting started here on Earth. And this thing isn't just sitting still. It's what's left of a star, a stellar corpse about the size of a city, and it is screaming through space at 60 kilometers per second. That's fast enough to cross the entire United States in just over a minute. Okay, so what exactly are we looking at? Its official name is PSR B0355+54, and at first glance, this thing looks like a cosmic bullet just shooting its way through the galaxy. But as you're about to see, there is so much more going on here. So, first things first, what even is a pulsar? Well, picture this. You take the core of a star way bigger than our sun and you crush it down into a ball no larger than a city. Then you spin it hundreds of times a second. As it spins, it blasts out these beams of energy, and if those beams happen to sweep past us here on Earth, we see a pulse, kind of like a cosmic lighthouse. And this particular pulsar has been on a wild ride. It was born in a massive supernova explosion more than 500,000 years ago, and today, it's just blazing a trail through the interstellar medium, that's just the thin soup of gas and dust between stars, and it's doing it all with its own powerful particle wind. Okay, so you've got this cosmic bullet plowing through all that gas and dust. What happens? Well, it leaves a trail, a big one, and for a very long time, the story of this pulsar was written right there, in its own ghostly wake. For years, astronomers used X-ray telescopes like the amazing CHANDRA observatory, and they got what seemed like a really clear picture. They could see the pulsar's powerful wind just slamming into the surrounding gas, and that collision created this huge, glowing structure called a pulsar wind nebula. And wow, what a weird trail it is. Astronomers found this really complex structure with some pretty funny names. There's a mushroom cap at the front, a long tail that stretches for light years behind it, and even two faint whiskers that poke out to the sides. This whole thing, this pulsar wind nebula, is exactly what you'd expect to see from a super fast pulsar. It's basically a cosmic traffic jam. The pulsar's wind is moving so fast it creates a bow shock, kind of like the wake you see from a speedboat, leaving this really clear, coherent trail in its path. And this isn't just a theory. A study back in 2016 using that CHANDRA data pretty much confirmed it. The whole thing looks like a comet, which shows that the pulsar's own wind is getting pushed back by something called ram pressure, which is basically just the force of plowing through all that interstellar stuff. The conclusion seems simple. It's a clear, stable picture. So everything lines up, right? Case closed. We see the bullet, we see its wake, easy. But what happens if we zoom in? If we look past that wake and actually check out the engine that's driving this whole thing? And this, right here, is where our simple story gets complicated. We're going to shift our view now. We're moving from the X-ray picture of the nebula to the radio picture of the pulsar itself. We're going from looking at its journey to listening to its very heartbeat. Now you have to understand, for almost every other pulsar out there, its radio signal, the average shape of thousands and thousands of its pulses, is incredibly stable. It's a unique fingerprint for that star. So reliable, you could practically set your watch by it. But then, in 2024, the massive 500-meter aperture spherical telescope, they call it FAST for short, took a look at B0355+54. And what it found was, well, it was a total shock. It found that this pulsar completely breaks the rules. Its fingerprint is anything but stable. So yeah, that simple story we had about a cosmic bullet, it's about to get really, really weird because we're about to uncover a deep mystery right at the heart of this star. Just look at this comparison. On the left, that's what we expect to see from a pulsar, a nice, consistent, reliable profile. But on the right, that's the chaotic reality of B0355+54. Its shape changes like crazy from one observation to the next, even when you average together 45,000 individual pulses.
So how do scientists even measure this change? Well, it's pretty clever. They look at the two main peaks in its radio signal. Then they just measure the ratio between the height of the first peak and the second peak. For any normal pulsar, that ratio is rock solid. For this one, it's all over the place.
Okay, check this out. In one single observation, at lower radio frequencies, that first peak is way weaker than the second. But as you go to higher frequencies, you see it get stronger and stronger until it's way taller than the second one. A nice, clear trend. But then, you look at a different observation, and the pattern? It's gone. The ratio starts low, it gets stronger in the middle, and then it gets weaker again at the high frequencies. It's not just changing, it's changing in a completely unpredictable way. And this is the bottom line, straight from the 2024 study. Not only is the pulsar's fingerprint unstable, but the way it's unstable is also constantly changing. It's like your signature looking totally different every single time you write it. So this leaves us with this incredible puzzle. We've got two completely different views of the exact same star. A stable, predictable traveler on the outside, and a chaotic, unstable engine on the inside. It's a fantastic mystery for astronomers to solve. This cable just lays it all out perfectly. You have two amazing telescopes. CHANDRA looks in X-rays and sees the wake, and it tells a simple, stable story. But then the FAST telescope listens in radio waves to its heartbeat, and it hears a totally unstable, shifting, and unpredictable engine. And that's really the heart of it, isn't it? We can see with perfect clarity where this star has been and where it's going, but we don't understand its most basic function, its very heartbeat. It's a huge reminder that every time we build a better tool to look out at the universe, we don't just find answers, we find much deeper and way more interesting questions. So what is this pulsar trying to tell us?